Hello everybody, welcome to the first of the 3 recordings on applications of Bayes' theorem. Please make sure that you have downloaded this document that's showing on the screen right now, Applying Bayes' Theorem. It's on Blackboard, and please go ahead and read through it at least once before you continue with these recordings. Alright, so if you've read through it, then you will know the basic setup here. What we've got is a result called Bayes' theorem, which is especially applicable when you have screening test results that are of interest. In particular, Bayes' theorem helps you calculate, amongst other things, the positive predictive value of screening tests. Let's set some key concepts up here. When you have a screening test for a disease or a condition of some kind, one of the interesting statistics for that screening test would be the sensitivity of the screening test. Now, the sensitivity of the screening test is simply a measure of its ability to give the correct result when the condition is present. So if it's a screening test for a disease, the sensitivity is the probability that the test is positive when it's applied to somebody who actually has the disease. Right? Sensitivity is the probability the test is positive when the disease is actually present. Also, we're interested in the specificity of screening tests. The specificity of a screening test is the probability that the test turns out negative when in fact the subject being tested does not have the disease. Clearly, we'd like both the sensitivity and specificity of screening tests to be high. We're also going to need the prevalence of the disease in the population of interest to be known. Okay? All of these three probabilities need to be known in order for us to be able to figure out the positive predictive value of the test. What is the positive predictive value of the test? Well, that is a probability as well. It's the probability that a person who has already tested positive actually has the disease. That's obviously, from a patient's perspective, when we're talking about medical screening tests, a very important probability. If you have a screening test performed and it comes out positive, that doesn't mean that you definitely have the condition. It means that there's a certain probability that you have the condition, and of course we'd like to know how high is that probability. If my screening test result comes back positive, I'd like to know, well, what are the chances I really have the disease? Alright, so to work out the PPV, we've already mentioned, you need to know the sensitivity of the test, the specificity of the test, and the prevalence of the condition for which the test is supposed to detect. All right, so there'll be 3 approaches for figuring out that positive predictive value. First of all, I'll give you the formula that every epidemiologist knows. We'll just give you the formula, we'll plug into the formula, that will tell us what the positive predictive value is. And this formula actually is a result that comes from Bayes' theorem, so there you go. The formula that epidemiologists know is that the positive predictive value of a test is equal to the sensitivity times the prevalence. That product is divided by this entire quantity. The sensitivity times the prevalence plus 1 minus the specificity times 1 minus the prevalence. Now let's go back to the digital mammography example upon which this document is based. Suppose that the sensitivity of digital mammography for detecting breast cancer is 0.8. And suppose that the specificity of digital mammography is 0.95. And let's suppose that in the population that we're looking at, the prevalence of breast cancer is 0.015. Well, we've got the sensitivity, the specificity, and the prevalence. Those are the quantities that are needed for the positive predictive value calculation. Sensitivity and prevalence, 1 minus specificity, and 1 minus prevalence will also need to be used. Simply plugging those numbers in, so there's not much more to do here except follow the formula, plug in the numbers, you get a positive predictive value of 0.1959, about 0.196, and that we would round to 0.20 to 2 decimal places, let's say. What does that mean? Okay, that means that a woman whose digital mammogram is positive in the age group that we're considering has actually about a 20% chance of actually having breast cancer. All right, so that's obviously a very important number from a patient's perspective. You can see here that the chances are, while they're probably too high for the patient to feel good, the chances are actually not that high that the patient has breast cancer. about a 1 in 5 chance, even after the digital mammogram comes out positive. All right, so hopefully if you're presented with a screening test problem where you can easily identify the sensitivity, the prevalence, and the specificity, you can plug into this formula to figure out the positive predictive value. All right, that's the end of the first recording. In the next recording, we're going to discuss a simple counting technique for calculating the same positive predictive value.